everyone. This is a quick intro. We're going to do a couple of videos, one on pipelines, one on kind of very basic intro to Scikit-Learn for those of you who may not have used it before. I know some of you have done machine learning classes in R, so we wanted to kind of do a very quick overview of intro to Scikit-Learn, and then we'll do one video on models and hyperparameters for those of you who have used Scikit-Learn before, or even sort of are using other tools, PyTorch, getting an understanding of which hyperparameters to use for which types of models, what makes sense, what doesn't. We'll do that separately. So we're going to have these three different ones. This one is basically a very quick intro to Scikit-Learn for those of you who haven't used it before. So if anybody else who's familiar with it, feel free to skip it. Yeah, so Scikit-Learn is just one of many packages that exist in Python to do machine learning models. It has certain models in there. It doesn't have every model that you want to use, but it has a lot of them. So, so we're not requiring you to use Scikit-Learn. It's just one commonly used package. So some of the quirks I'm going to talk about are specific to Scikit-Learn here. Right, so let me sort of share some skeleton code that I wrote to kind of to show you guys how to use Scikit-Learn typically, right? So first thing is you're going to have to import Scikit-Learn packages, and you can import a whole list of them, different types of models, different pre-processing, and so that's something to look at when you're trying to figure out what to import. The first step is really to create connection to the database, or if you're using CSVs, load from the database, from the CSVs, right? So I have a function at the bottom here that creates a Postgres connection with a credentials file, and then creates this string that you're all hopefully doing already. So creating that connection to the database, and then we're assuming here that you've done a lot of that pre-processing already. You've created your features, you've created labels, and all of that stuff is sitting in tables in Postgres. So now that we've done all the hard part in SQL, we're going to get it into Python to build Scikit-Learn models, right? So the first thing is that we're going to get our training set that we've already designed, and that might be sitting in a table where you would do some select statement where date equals, remember in our matrix, the start date for the rows and the end date for the rows. So you would give those, where date of row is greater than something and less than something, and that gets your training set. And then stores it in a data frame called train.df. And then we're going to do the same thing, load that matrix from the database for the test set, where you would have a different start date and end date. That's your validation df. So now that you have those two, what you need to do to build Scikit-Learn models is, one is you have to define what columns in your data frame are features. And that's why you probably remove things like identifiers, right? So your student ID or bill ID or the date, things like that. So you would kind of make a list of all of them. And of course, you don't have to list out. This way you can be smart about, if you want to be more efficient, you can for loop over and remove the ones you don't want rather than include the ones. So by default, they're included, and remove the identifiers and any other things that might cause leakage. So, but there's a list you want to generate there. And then you want to give it the column name that has the label. And you might have different labels. For example, some of you might have a 3-year graduation versus, 4-year graduation or something like that, recidivism. So now that we have our training set, validation set, the list of features, column names of features, column name of the label, we're now going to just create, our training features and our training label, and our validation features and so the data. So now we're separating the validation set on the features and validation set for the labels. So now and again, what we sort of skipped here in the middle, by the way, was missing values, imputation, converting to dummies, all of that stuff that's hopefully you've already done before you store it into the database, but you can also do it here. Dealing with missing values, doing imputation, converting your categorical to dummies, doing scaling, but that's kind of going to happen before that, right? And in each of them separately in the training and validation. So now you have this data prepped, and the first thing once you have all that set up is you have to define what model you want to build. And we'll go into that in the next video, a list of all the different models and hyperparameters. And here I'm just picking the most basic with no regularization, nothing, just a plain logistic regression. So I define model equals this. And the nice thing is that model equals whatever, so if you put in decision tree classifier with different things or random forest classifier, or it's the same syntax. So that's one of the reasons why these packages are nice, because you can use the same object, same syntax to run different models. So once you've defined whatever model you define here, fitting the model specific, this is a model specification right now. And so then the dot fit is the function that takes in the features and the label and builds a model in this model object. So that's going to fit a logistic regression model. You can print that to see what the coefficients are, what the intercept is, all those different things. And if you use sort of nice statistics about these models, Scikit-Learn for logistic regression actually doesn't give you a lot of useful things when you print it. Like stats models and another package that gives you much better results, much better information about your model, your standard errors, and a bunch of things that if you've been using other packages in R, for example, you might be used to. You might also want to store your model, so you can store it as pickle, where you might define a pickle file name and then just dump this model. Make sure you import, pickle at the top if you want to do that. And then, here's this, if you wanted to load that back at a different stage to do things in batch, you can also load the model from a pickle object. So, okay, so now we trained our model. We can look at it, we can print it out, we can see if it's a decision tree. You might want to print out and see what the tree is. If it's a random forest, printing it may not help you very, very much. So now we want to take our validation set, the features, and generate scores for them. And again, this is the function to use, right? Predict proba. Remember, never ever use predict in Scikit-Learn because it assumes a 0.5 thresholds and give you a 0-1 output. So that's bad. Because we're dealing with a binary classification problem here, we're going to take the score for class 1 in this case. So this generates predictions for every scores for every class in your data, because you only have 2 classes. It's going to give you a score for class 0 and a score for class 1. And we're going to store these for class 1. You might want to actually, good practice to look at the score distribution and see what am I getting. So this is good to do. Just take the scores, look at the histogram, the distribution. So now for this training and validation set, we built the model, we scored it, and now we want to see how well we did, right? And here I'm generating metrics in one way. That you can, you're going to do it various different ways for your projects, depending on if you're taking the top 10%, top 2%, top 20%, top 50%. So in this case, I'm saying anything above 0.8, that's my threshold, is a 1. Anything below that is a 0. So I'm picking a 0.8 threshold. And again, for most of your projects, you're not going to pick necessarily a score threshold. You're going to cut off at the rank, right? So you might say the top 10% are a 1, the rest of them are a 0. But basically, this results in converting those scores to 0-1 values. And that kind of becomes the predicted 0-1 values, and the expected 0-1 values are what your label column was. And so now you can do all the different, Scikit-Learn gives you different metrics, and different functions. So one of them is a confusion matrix, where you give it expected and predicted. And again, this is already now 0-1, right? We've already converted them, and you can print the confusion matrix. You can do a precision at that threshold, right? You can do recall. So this threshold is score, but you can also, you're going to do it, most of your cloud projects would be for the ranking. And that's mostly it for the basic Scikit-Learn intro. It's get data, do all the pre-processing, make sure you define features in the label, generate training features, training features, training label, validation features, validation label, define the model, build the model, look at the model, possibly store it, score the validation set, look at the distribution, and then select the threshold, top 10%, 0.8, 0.7, convert those scores to 0, 1 predictions, and then generate a confusion matrix, look at precision recall, and then you can add here the precision recall K-curve, right, which doesn't need this step. It just takes these scores and the labels directly, and now you can calculate this precision recall at different thresholds and use a function to generate that curve. So hopefully this was useful. There are many good resources for Scikit-Learn, so I didn't want to do an exhaustive thing here. There are lots of videos, lots of tutorials. It's a well-documented library, so but happy to talk in office hours or the check-in sessions if you want more pointers.